Hi, and welcome back to day 6 of statistics. Today we are talking about bivariate statistics. Bivariate statistics is used to compare two sets of data. For example, height and age of a child, weight and age of a child, height and weight of a child, and homework average and class average. In order to represent the data, we use a scatter plot. Correlation is a relationship between the data. Linear relationships would look like a line. The correlation is positive if the slope of the line is positive, and the correlation is negative if the slope of the line is negative. So what we have here are 5 different examples of types of correlation. Up here we have a strong positive correlation. When you plot the data, it looks like it's almost in a line. We have a moderate positive correlation where you can kind of see that we are going to have a line and they're pretty close, but they're not exactly all the same. No linear correlation means there's a bunch of points just plotted all over the place. A moderate negative correlation looks like it's kind of going to be a negative line, and a strong negative correlation looks pretty much like a line. So what are we going to do with this stuff? Well, we are going to talk about regression lines as well. A regression line is a line that approximates the data. It is also called the line of best fit. You may remember talking about this back in 9th grade. We will do this by using the graphing calculators. The regression equation is sensitive to rounding. So you round the coefficients to at least 3 decimal places. Okay? At least 3 decimal places, unless you were told otherwise. So let's try this. Jacob joined an exercise program to try to lose weight. Each month he reports the number of months in the program and his weight at the end of the month. His record for the first 12 months is shown below. Okay? The top line is always X, the bottom line is always Y, which means this is always L1 and this is always L2. Okay. Try a scatter plot and describe the correlation between the data, if any. Well, a scatter plot is just a graph. On the bottom is my X, and those are going to be our months. So we have 12 months. Alright, and this is going to be our weight. And his weight range anywhere from 170 pounds all the way up to about 250 pounds. Well, we can't list from 0 to 250. So I don't know if you remember doing this with your graphs, the histograms in 2nd and 9th grade, but you need to have a break in the data before you start. And then we'll start with, this would be 170, 180, 190, 200, 210, 220, 230, 240, 250. Right? It's not perfect, so it's kind of hard to draw a graph like this. And then we just go through and we plot our points. So at month 1, so you can see what we're doing. So month 1, we were at 248, which is close to 2. Month 2, we're at 242. Month 3, we're at 237. Month 4, we're at 228. And then month 5, we're at 222. Let's get a little bit closer over there. Month 6 is 216. Month 7 is 213. Month 8 is 206. Month 9 is 197. Month 10 is 193. Month 11 is 185. And month 12 is 178. Okay, those are approximate, obviously. So this is a scatter plot. In a scatter plot, you do not connect the points. B, draw a line that appears to represent the data. Well, let's put our line that we can draw here. The line that represents the data is going to kind of go through most of the points, as many points as you can. And it's a line. Pretend that I'm using the straight edge. And I'm either touching or going through most of the points. So that's part B. Part C says write an equation line that best represents the data. This is where the calculator comes into play. We go to Stat, and we're going to calculate. And we want to do, like I said, calculate, so it's calc. And then we want number 4, which is lin reg ax plus 2, which means linear regression. And then you want to have L1, L2, comma, Y1. And to get Y1, you hit your bars button, and then you arrow over, and you do Y bars. Number 1, which is a function, and then number 1 again, which is Y1. And then, what I want you to do on your calculator is hit zoom, number 9, which is stats. And what that will do is give you a picture of your scatter plot along with the line that we choose. So you'll have a graph that looks very similar to mine, except it'll look a lot nicer than mine. And then C says write an equation of a line that best fits the representation of the data. So this is what we do when we look at the actual graph. At this point, if I hit enter, if I hit enter here, a bunch of data will pop up on my screen, and I will get the equation rounded to at least three decimal places. Y equals negative 6.283x plus 254.5 9, 1. If I look at my graph, if I were to try to classify this, I would classify this as a strong negative correlation. Because it looks pretty much like a straight line. For number 2, in order to assist travelers in planning a trip, a travel guide lists the average high temperatures of most major cities. The listing for Albany, New York is given in the following table. We have 1 through 12. And it says, can these be represented by linear regression? Well, only thing we can do is put this into L1 and L2. And after you do that, you want to hit y equals on your calculator, and you want to make sure your stat plot is on. Okay, and that's second y if you need that. Equals, make sure your stat plot's on. There's 2 ways to turn it on. And then you want to hit zoom number 9 and stat. And you want to find out if it would look like a line when you plot these points. It looks linear or not. We will save this for class on Monday. So the notes aren't too long. The only other way to do this is just to plot a rough scatter plot. But when we have the calculator at our disposal to do this kind of stuff, we might as well take advantage of it. So Monday in class, we will finish this problem up with our graphing calculators. Alright, have a good weekend. See you on Monday.